Welcome to Smart Manufacturing Mindset, where we challenge guests to think differently about manufacturing. We'll explore the nuances that hide in plain sight behind the acronyms, techno jargon, and misinformation to get to the truths that hold real value for real people in the industry.
Hello and welcome. My name is Mike Yost. I am your host, and I am glad that you could join us here today for the next installment of the Sesame Smart Manufacturing Mindset LinkedIn Live series, where in every episode we challenge ourselves and our guests to think differently about smart manufacturing. We challenge ourselves to think differently because we think it's time to stop asking what smart manufacturing is and start figuring out what it means for each of us. And central to that work is education. So I am really excited that we have three of Sesame's academic partners here with us today to talk about bridging OT and IT systems at college industrial labs. So please welcome to the stage here with me, Sam, Samantha. Hi, Sam.
Hi.
Sam is a professor of physics and coordinator of Smart Systems Technologies at Finger Lakes Community College in New York. Thank you for being here. We also have Joe Ciuffi, assistant teaching professor and the EMET program coordinator at Penn State New Kensington. Hi, Joe.
Hello, everyone. Hello, everyone.
Could you quickly define what EMET stands for? I didn't ask you that before.
Electromechanical Engineering Technology.
Fantastic. Thank you for joining us here. And last but not least, we have Thorsten Wust, the professor of mechanical engineering and program director of industrial engineering at the University of South Carolina. Welcome, Thorsten. Well, thank you all for being here. And these are the gentlemen that everybody wants to hear from, as do I. And we will get to them after a few housekeeping items here for us today. First of all, I would encourage you that if you're not familiar with Sesame, that you get to know them. Sesame is the National Institute on Smart Manufacturing, a public-private partnership that is building the smart manufacturing ecosystem in a number of different ways, but through events like this for sure. And this series would not be possible if it wasn't for SME and their support and co-producing these webinars. So we thank SME for their support. Our goal with this webinar series is to zero in on a different way of thinking as a modern day manufacturer. We are obviously streaming on LinkedIn Live right now. We welcome your comments. And if we are able to work them into the flow of discussion, we will. If not, these conversations live on LinkedIn well after the live show. So feel free to continue to throw your ideas in and discuss the topics raised here today. We are recording the event, so you'll be able to watch it as many times as you like. And lastly, I would encourage you to follow Sesame on LinkedIn and check them out online at sesame.org. Where you can find a lot of information about Sesame and their mission and their projects, their membership models, and much, much more. So with that, let's get on to the show and start talking about bridging OT and IT systems at college industrial labs. So gentlemen, I'd like to start by letting each of you talk just a little bit. And Thorsten, we'll start with you. Can you just briefly describe your institution's approach to smart manufacturing education and how you are preparing the students so that they understand and work with both IT and OT systems?
Absolutely, Mike. And I have to give a little bit of a background because I just changed institutions, right? So I will talk a little bit about what we did at my previous institution at West Virginia University, and then go over what we plan to do here at the University of South Carolina. So in the past, we were lucky enough to get a Sesame education grant to build a curriculum for smart manufacturing, which really helped us to first understand the real challenges and needs in that space. And that includes that students have access to physical systems, or at least simulated physical items, right? In order to really interact with the system. Because what we learned is that when we teach them on PowerPoint slides and just virtually, that is not IT, OT, and they are unprepared or underprepared, right? One major challenge is that these systems are really expensive and not that accessible, right? If you can afford them, you have to find space to put them and maintain them, right? That it's not feasible for every institution and not for large programs because you would, I see, I have to put my speak a little louder. All right.
Excellent.
so that now I lost my train of thought. So that all students have access to that, right? Because when you have a class of 100 students and you want to do hands-on experiences with them, that puts quite a strain on the system available, but also the technical support that needs to be there to help students with that. Now transitioning to
We're having a little trouble with your microphone, Thorsten. I'm going a little hollow there. Maybe you can work on that. We can introduce one of the other guys and then circle back to you. We can pick it up on the where you were talking about the future with South Carolina. So Sam, why don't we do the same with you? Just tell us about how you're preparing students and the students that you're working with in your institution's approach to smart manufacturing education.
Sure, Mike. So ours is a 2-year associate in applied science degree program where students learn to work with combination of hardware and software. This basically includes PCs, data acquisition hardware, cameras, microcontrollers, Raspberry Pi, FPGAs, PLCs, motion controllers, and robots. And software, the basic Microsoft Office suite, LabVIEW software, Multisim, MATLAB, Simulink, C, Python, and some vision-specific software. Platform for sensors, data acquisition, machine vision, data analytics, and automation, feedback control, as well as remote control. And crucial part of that education is a required co-op among about 50 diverse industries where they learn industry-specific skills.
That's excellent. You said it's a 2-year degree that you're delivering?
That's correct.
Excellent. Let's circle back and see if Thorsten's microphone's better and let him finish his thought, Joe, before we come back to you. And Thorsten, just I guess to the audience question, yours is a 4-year program. Is that right? Okay.
Is the microphone better? I changed to the computer integrated one.
It's a little bit soft, but at least I can hear you.
Yeah. All right. New equipment, but yeah, coming back to what we're planning to do here at USC, as you said, a 4-year program and actually a brand new one. Right now, there's an aerospace and mechanical engineering program that has a lot of smart manufacturing components. But what I'm really excited about is the new IE program that will start next fall. And to the best of my knowledge, is the only one in the US that has a mandatory smart manufacturing class included in the curriculum. So the students will get exposed to it, not as an elective, but as a core part of the program. And with that come access to, similar to Sam, like facilities with like multiple robots, digital twin setups with a full Siemens suite and all, including a multi-stage smart manufacturing system from Festo that we plan to bring here and install to integrate with the existing labs here. So we will have a lot of hands-on activities, both on the software and IT and OT side.
Excellent. Thank you. Joe, how about you? Fill us in on what you guys are up to and how you approach this topic.
Of course. So electromechanical engineering technology has sort of evolved over the years. It's a 4-year program, and it essentially has evolved into a degree in industrial automation. And frankly, it's tough to fit everything in. We have enough electrical engineering to be dangerous, enough mechanical engineering to be dangerous, and all the automation and programming that bring it together. So adding on sort of the data and networking, smart manufacturing is tricky, but we've done the technical elective, and we've been running the smart manufacturing technical elective, which has been helpful. We also have we started a sort of education and outreach center for local manufacturers called the Digital Foundry at Penn State New Kensington. It's one of the SESME Smart Manufacturing Innovation Centers. We have interns there. We run classes there. It is a space entirely dedicated to demonstrating the power of smart manufacturing, data systems, interconnectivity. So we've been exposing students down there in a variety of ways, internships, a couple of our classes, to help do that, give them exposure on top of our already sort of heavy curriculum.
That's excellent. Lots of guess lots of powerful things I hear wrapped up in there. You talked about different components from all of you, not just Joe's response, but internships and co-ops and 4-year curriculum, 2-year curriculum, integration with the innovation centers. So it just shows the breadth of the work that's going in from an assessment perspective and their partner ecosystem around the education. So, so Joe, let's stick with you. I'll go back around the horn because the topic here is about integration of IT and OT, and that's been a well-known challenge in industry for as long as I've been around. So how are your institutions approaching the integration in a lab environment? And maybe talk a bit about the specific challenges that you're running into, and how you're thinking differently to overcome those types of challenges. Joe, you want to start with that?
Absolutely. And what's crazy is we've run into this time and time again when working with manufacturers at our Digital Foundry site. But I see these parallels almost exactly to industry and academia in this way. You'll find that there are very highly protected systems, typically centrally managed PCs, firewalls to data, and then you have a bunch of folks who want to add on equipment and tinker and pass around data and keep it open access. So you see that in industry on a natural factory floor, but then you also see it in academia where we have systems designed to protect student data, and we have managed PCs for them all to log in on and do stuff. But then we want to come in and add a bunch of non-managed machines and equipment all plugged into the network. So it is almost an exact parallel with what we're dealing with. I think what we've sort of had the best luck with, at least in conveying our needs to the academic systems, is that we need these dedicated IoT networks. And that tends to resonate with them, where with the modern way of setting up network address translated sites and VPN zones and carving out different local networks, letting them know that this is what we're dealing with. We're trying to get machines and parts and pieces all on the same network, and then work with them to sort of manage what has local access to it, what punches through the various firewalls. And it's literally the same thing we've done with manufacturers.
Yeah.
And so that has been a very powerful thing. And that, for me, the thinking differently about it, which is very important on my end, is typically in academia, we work with IT to get certain software installed on machines. And the whole process is getting software approved to put on the network. It isn't anymore. I have to meet with them early, carve out entire network systems to be able to install all the lab equipment. And so they really become a partner, just like OT and IT and a site. They become a partner to think from the beginning of the architecture of what we're laying out, not just specific software. That's been the biggest thing for me, and that communication is critical.
Excellent. And Sam, how about you? From your organization's perspectives, the same question: challenges from an IT, OT perspective, and how you guys are thinking differently.
So I would echo what Joe just said in terms of working with them in planning and then execution part. So at our college, with respect to IT security concerns, our whole lab is separated on a separate network compared to the rest of the college on a virtual LAN. And for our students, some of our students are remote students. So we have a high flex scheduling option, which has become very important because we have some students who are incumbent workers and sometimes they try to connect from the workplace. And then we also need to be able to provide asynchronous connectivity to some systems outside the usual hours. So we created a secure socket LAN VPN, secure SSL, secure socket layer VPN, for which the students have to be registered students in specific courses, and they can then given access to it from home or elsewhere. So this is only access to 5 desktop. These are the desktop which have a bunch of hardware, software, or more specifically, they're also connected to Sesame Smart Manufacturing Learning System. And that has been very helpful because through the project we did with Sesame and Amatrol, we are learning a lot in terms of some of these issues and how to train students with those skills.
And does that allow you, Sam, back to Joe's earlier point about tinkering and adding things? If you're using the Sesame system there, does that give an environment where they can safely and securely do that tinkering?
Yes. And to that end, we also extended the capability of a smart manufacturing learning system by being able to connect inexpensive sensors using Arduino, for example. We have dozens of hundreds of those sensors. And then Arduino can communicate using wireless network to Board Connect on smart manufacturing learning system. And thereby we are able to increase the use of different resources. And students are able to experiment with those things themselves in the class and in some cases outside the class.
Oh, that's fantastic. So Thorsten, let's get you in here. I read a paper of yours, case study that you did on this topic, and I know you got plenty of stuff that you can talk about here. So you want to weigh in on this topic?
Absolutely, and I don't want to repeat what Sam and Joe said because I couldn't agree more. So I will give you one example that was also the reason why we wrote that paper. When we bought a new manufacturing machine and it was delivered with the outdated OS, right? So IT said, no way that goes on a network, and they were right. Like, I mean, it was unsupported Windows, right? Like it's cyber secure, not at all. So there are certain hurdles that come with the territory, because a lot of these machines are normally not connected by regular manufacturers, at least not yet, right? So and then at a large organization like a major university, you have central IT, which is, as Joe pointed out, focused on keeping student and personal data secure because they don't want to get sued, and that's of course really important. But it's contradicting some of the things that we need to do in our smart manufacturing environment. So what we have in both West Virginia University and USC, we were lucky to have a local IT department at the engineering school, which is more in tune with what computer science and manufacturing engineering might need, right? And are more open to listen and build a virtual environment that is secluded, set up firewalls, allow us more things than central. Nevertheless, it's really important to go there and introduce yourself and take them to the lab and show them the machine, because sometimes when you talk about that 3D printer, they do think of a regular printer that prints paper, right? And it's a very different machine. Right. So just build that relationship, just as Sam and Joe were saying, introduce them, explain, and then work on it together. Like, solve these problems. Don't be too, pushy and say, like, we need to do it that way, but find a solution together where IT is comfortable with, and what you can work in your lab as well. So I think that would be my main advice. Take them to the lab, show them what you want to do, explain why you want to do it and why it's important, and then hopefully you'll find a good IT administrator that is, open-minded, and then it can be resolved. The people skills, right? The people skills.
Yeah, and it sounds, to Joe's point, like the parallels between what you're dealing with and what industry deals with are striking. And
I mean, export control, right? When you have defense projects and secure data, all of a sudden they have to be very, very, very tight on that, because otherwise it can go south really quickly.
Yeah, for sure. So Sam, I think all of you have talked about a whole bunch of different industry partners, different technologies, different systems, different sensors and things like that. So how do you go about engaging with industry partners to ensure that your labs and your curriculum are aligned to what manufacturers need and the different types of solutions and such that are out there today? I guess, what role do you see these collaborations playing in this IT/OT world as they continue to come together? And is there a role that Sesame's playing there to help facilitate that?
Sure, Mike. So our program originally started out 13 years ago as Instrumentation and Control Technology Program. That was the title chosen at that time. the origin was the county economic developer as well as some high-tech business leaders have informed us, and also interactions with them, we realized that there was a need for a new degree program. And so industry at that time, we had about half a dozen partners to begin with. That collaboration has increased now to over 50 businesses. So they are about a dozen of them are on our advisory board. And as some of them retire or leave, go somewhere else, we replace them by others. And slowly we are beginning to be able to add even some of our own graduates who have been working with some of these businesses for some years. So I say that these businesses span a whole high-tech ecosystem, whereby I mean we have businesses in telecommunications, optics, machine builders, to food manufacturers, and so on, packaging companies, small, medium, large, mostly small and medium companies. Majority of them have visited our labs, some more than once. And every fall, we take students out to visit a dozen of them in the first semester. It is part of their socialization, part of their first year seminar class. And during the visit, they see how businesses address OT, IT challenges, again, different use cases. Students are required to do minimum of 270 hours of co-ops. These are paid, and almost everyone continues working many full-time before they graduate. And as I mentioned earlier, in some cases, we have incumbent workers who too bring to bear their experience in this context, OT-IT integration, and help us and fellow students to be aware of issues and options for solutions. In our case, Sesame is opening our eyes to OT-IT integration examples, challenges at baccalaureate and research institutions, and industries small, medium, large, along with resources at other national and international scale.
And just one point, Sam, when you talk about incumbent workers, you're talking about workers that are already out in industry and they're coming back to get more education. Is that accurate?
That's correct. So currently, most incumbent workers, if they want to pursue technical program, it is very difficult for them because the class times would conflict with the work time. And on top of that, you have people on 24/7 schedules, which are not always consistent. And we are able to provide an option for them. So they come in the class when they can. Other time they connect from the work, and sometimes they look at the recording of the class and catch up.
Excellent. Well, thank you. Thank you for that. And that's really important. I think it also shows the breadth of the education and the need to reach people where they are and how many people need to be educated. Thorsten, I was wondering, we've been talking a lot about hands-on experience and how crucial that is in understanding manufacturing. Can you talk about success stories or examples of how you've been able to facilitate hands-on learning in your lab spaces?
Absolutely, yeah. And okay, I'm coming closer again, just so you can hear me.
Perfect.
One great example is the recent Sesame educational project that we had together with our industry partner Festo, where we built a curriculum that could be adjusted to different audiences, from K-12 to workforce, which I believe was very successful, and we have taught it multiple times at WVU. It's taught at a technical high school up in Erie, Pennsylvania, and the University of Arizona and others have already at least partially implemented some of the content to their programs as well. And that has a large component of practical hands-on activities, ideally centered around a Festo technical system with PLCs from Siemens, right? But we know that not everybody has that. So we build in, data sets that we collected from that system, so others can at least get the learning from interacting with the real data set and applying machine learning and other analytics methods to get that part of the practical hands-on activities within that curriculum. Now we went a step further. Matt McCormick, a PhD student in my lab, has taken it on to enhance the capabilities of that Festo systems and installed cameras and additional sensors for energy capture and so on, and build a whole architecture to collect real-time manufacturing data sets. Because what we realized, one big hindrance for education on the one side and research on the other, which go hand in hand, is access to real manufacturing data to compare what you try to do to learn, to bring forth, like a similar ecosystem that computer science has due to widely available data. So that's currently published. We can post a link here in this stream if you like. It has a sample data set attached to it that everybody can use that and interact with it. Stream it real time, so you can build a real application that basically simulates a system that produces data and as a time series. So you can build all the follow-up backend on that data. And I think that is how we want to approach that moving forward, to make it more accessible and scale it. Because otherwise it's just small scale solutions that just few profit from. In this case, the whole community can take it, work with it, and hopefully others will contribute their data sets to it as well. So the ecosystem will kind of amplify itself. So that's our ambitious goal. Let's see if we can achieve it.
Yeah. I guess maybe an add-on question for the whole group here after one point. I guess just the Thorsten's point about the Sesame funded curriculum project with Festo. I mean, that just shows the all-encompassing work that Sesame is doing to invest in work like that, in addition to research projects and implementation projects and other things that are going on. So again, more information on those sorts of things can be found on the Sesame website. But I just wonder, when we talk about hands-on, are we talking about full-scale production level? Are we talking about benchtop level? Sam's talked about witnessing things online. Just thoughts from the group here. Is it all of those things? What does hands-on typically mean? Joe, you want to start?
We have a lot of benchtop style systems and as many mock systems as we can possibly take time to build or pay for. I think for me, like, senior design is important. And I have a interesting quick aside relating to working with industry. This is the first year in working with a few sort of corporate sponsors for senior design that medium-sized companies have requested, sort of top line, that no matter what widget we build for them, it integrates into their SCADA and MES. So they're going to have requirements coming in on the networking side and how they want it to communicate out. So I'll just throw that in there.
That's fantastic. So anybody else from it? Is it production scale? Joe mentioned benchtops. Is there anything else to cover there?
Well, I will quickly mention, instead of a success story, a story of failure. So we have a Omron collaborative robot, Techman robot in the lab, and a student was working on it, and he chose to put in a password, which he forgot, did not record it anywhere. Oops. And then the student had left for the summer. When he came back, he could not get back onto the system. And there was no way to reset it. So we had to wait until we had someone coming from Omron from some distant place and put in some dongle and do things to reset the password. So from then on, we are very careful about working with that kind of situation. And in terms of success, on the same robotic arm, one of the students, younger than 18, was working on a project, got some experience, and based on that, he was able to start a co-op at a local business, Optipo Systems, which happens to be Sesame member, by the way, and was able to help other personals. There were some co-ops from RIT, local Rochester Institute of Technology College, and he was quite effective and helpful in that project. So Thanks.
Yeah, no, we appreciate that. Appreciate it. So,
So Mike,
Joe,
maybe just one quick chime in with the benchtop or full scale. I think what we noticed is that full scale is great, but you need a lot of training and they're expensive to maintain. So for academic institutions, when there's no project or centrally funded, hub associated with it, that's difficult to sustain, right? You can buy it, you can get the first 2-3 years with projects, but who pays for the maintenance and the software then, right? That's the big question. So that's always tricky, but of course that's better for student learning in small groups when they're trained. On the other side, what we, for smart manufacturing in particular, and IT/OT integration specifically, we don't really need a full-scale like application, but the controllers and so on should be industrial scale, right? So a Siemens or Rockwell, and not some smaller subsystem, right? Because that helps them then later on when they transition to industry through internships or for full time to know how to interact with these systems.
Excellent. Thank you for that. We've been talking for the last half an hour or so here with Sesame Education Partners about bridging operations technology and information technology worlds in college lab settings. I don't think we can have that conversation without talking about cybersecurity. So, Joe, can I put you on the spot and talk to us about how you're addressing that? And let me throw it out to the group here about cybersecurity and how that fits into the education.
Sure, but I'm going to give sort of an embarrassing answer. I mean, the bottom line is it's very hard to cover in our curriculum. Again, we're so full with what we're trying to show. As Sam pointed out, even something as simple as passwords, I mean, security certificates, I mean, registering MAC addresses. We could spend entire labs trying to connect a PLC properly and turn on all the secure options for that system. And we haven't had time to do that. What I try to do in some of my materials and the Smart Manufacturing Tech Collective, give them a sense for what they would need to do and some of the vocabulary they're going to need to say to work with folks. But the bottom line is, unless we have dedicated labs to doing these things or carved out topics, it's very hard to make it make sense on the fly in an academic setting. However, what's interesting is that we have to start talking about it, and we have. Our curriculum committee, I mean, even though we're stuffed full of stuff, we've recognized that modern networking and cybersecurity may need to be an actual component of our program. That's what they're seeing in industry, period. And it is not going away. Modern networking is not going away. So again, right now, we're just trying to let them know that it exists and they have to worry about it. But I think in the near term, it's going to weave its way into our curriculum.
Sam or Thor, anything that you would add from a cyber perspective?
Yeah, we have, again, not been able to do much, but we introduce students to use of tool like Wireshark so that they can see what else is connected to the system and how to take, say, a new PLC or unknown PLC of unknown IP address, how to connect it to Ethernet adapter and reset the IP address for the PLC. And as I mentioned earlier, we have students learn to use secure socket layer VPN for remote control. And in terms of emerging technology that actually, that is a second question, Mike, you are going to ask, right?
Yeah, just talk about the trends and emerging technologies. Is that what you mean? Yeah, certainly would love your view, your thoughts on emerging technologies that you believe are going to be really important for your students.
Well, this year we have started introducing students to use of AI tools such as Copilot in order to start with some code snippets for Arduino or other software needs, even before they learn some of the software skills in a formal programming class. Other emerging technologies such as machine learning, digital twins, both at edge and in the cloud, connected workers, such as use of augmented virtual reality for remote interactions, remote expert advice, assistant, they are going to be increasingly important. And we like to give students a head start in that regards.
Thor, anything to add here on the trends and cyber security and such?
Just a quick note, because I think it's pretty aligned with what Sam said. On the cybersecurity side, there are cybersecurity bachelor programs in both the business school, surprisingly, and the computer science department that focus on that, but not just manufacturing, but grid and so on and so forth, right? So there are resources there where our students can take electives from, so they can bring that in. But in the program itself, it is covered very high level in certain classes, and similar to what Sam and Joe said, we try to instill it, but don't have the space in the curriculum to have a dedicated class at this point. Might change in the future. However, on the grad side of things, like for master and PhD, there's quite some research going on where the students interact with these systems and try to go ahead and find new ways of how cybersecurity can be play a bigger role in smart manufacturing and put less barriers up to be cyber secure, right? Because a lot of times that seems to be a major hindrance to actually connect systems. And then on the new and emerging technologies, one of our major research areas are AI, ML, and time series in the moment, combined with digital twins. So all the buzzwords together, but we actually do research on that stuff. So I expect that to make progress. With LLMs, we're a little bit hesitant because the results are not in the space where we would like to see them yet. And I guess the application depends. But we are exploring there how that can be productively and efficiently be used in our applications. And they're not going away, so we have to find ways of using them effectively and mitigate the hallucinations and other pitfalls that students might overlook.
Sure. Excellent. Well, appreciate the input. Appreciate all of the discussion here so far. And I think it's time for us to start to head toward a close here. So maybe, Joe, I can start with you. If there are other academic institutions that are looking to replicate or strengthen their smart manufacturing education programs, what advice would you guys offer to them? Are there lessons that you've learned that you could share or directions that you could point people in to help them emulate what you're doing or come alongside you and complement what you're doing?
I think, as we mentioned before, first and foremost, establish communication with your IT teams. But I would say that there's one important aspect to that. Many of us of a certain generation grew up in networking and computer age. However, I think we don't realize the modern way they're managing these systems, modern VPNs, virtual machines, NAT translation, all sorts of things. Take a minute as an engineer to learn a little bit, upskill yourself on modern networking. That will help you communicate with IT teams. That's my thing.
Excellent. Thank you. Thurston, how about you? Any recommendations for others?
Build a strong relationship with IT, obviously, but also with strong industry partners. Like Siemens is an excellent partner here that continuously engages, not just providing a license for software, but coming here, have staff on hand, and a really in-depth relationship, which is invaluable when you think of IT/OT integration, smart manufacturing curriculums. And then the other side is a motivational piece. I think the students really, really enjoy these types of courses, these types of engagement, smart manufacturing, and future employers recognize that. Like a few students that are now in the workforce came back and said, they believe that got them their job, that they sat at the dinner as an intern with the CTO, and he talked about digital twins, and they could chime in because they knew what that was, and that might have given them the edge to get the job, right? So it's not easy, but I think it will pay off when you invest in building up the smart manufacturing curriculums in your programs.
Excellent. Sam, how about you? Final thoughts here, advice you'd give to others?
First of all, institutions who are new to smart manufacturing, they should really examine resources that are available through SESME and Simani, other counterpart in Manufacturing USA institution. Look at some of the resources and understand definition as well as scope. So when I first started out on this journey, smart manufacturing meant to me something which was quite narrow. Now, when I look at some of the articles from Conrad Levia defining smart manufacturing on a much broader scale, then it becomes a much more bigger project. And so it's always good to hear from experts such as Joe and Thor as to what they're doing and learn from it. I think a day might come where all the compute is moved out to cloud. That day might come someday. But the real systems, your sensors, actuators, etc., are still physical. So they are going to be in your lab or at your business. So people need to understand that you need to have basic on the analog to digital conversion, both on the input side and output side. And that might change some of these challenges down the road. So it is challenging, and but it's great to be learning along with all of you.
Excellent. Well, and thank you. Appreciate that. Appreciate all the work that all of you are doing. I just want to thank you. Thank you, Thor. Thank you, Sam. Thank you, Joe, for being here, for contributing and sharing today. I would also, again, like to thank SME for their continued support of this series. They're playing a valuable role with SESME in creating this ecosystem and hopefully instilling a new mindset. So again, I just encourage anybody out there, everybody out there, to get to know SESME, follow them on LinkedIn, check out their website at sesme.org. These recordings are available on podcasts at Apple Music or Spotify. And then I would encourage you to join us again next month for our next episode. We typically host these sessions on the last Tuesday of every month. So join us on September 24th. And so until then, I would remind you that when you think of smart manufacturing, think differently. Thanks, everybody.
Thanks, Mike.